Okay, I don't know if this video will take forever. I really hope not, but standard 11.2. All right, so standard 11.2 is all about taking this format of the equation and making changes to it and seeing how the graph responds. So I know that if I have an x squared equation, I know that that makes a u shape, and technically that u shape would live right here at that origin, and ta-da, that would be it. And it would go out one in each direction because it's simple, it's got nothing else there. If I started to throw some numbers in the back or in the front and I started to mess with those numbers, that graph would respond in some sort of way, right? So here's what I mean. You have your little equation, y equals x squared. Right, so there's your parabola. I'm going to do some stuff to it. Let's put a plus 5 in the back. Notice that parabola left the middle, the origin, and moved somewhere. Well, what happens if we put a minus 5 there instead of a plus 5? Or other random things that Desmos decided to put in there. See? So now minus 5, it's been moved down 5. Well, what about if we put a minus 5 in front? Or just a regular old 5, right? So notice it changed the width of that. If I make it a minus 5, something different happens, right? So the whole time, every time I'm messing with the equation, the graph is like responding some sort of way, kind of like a cause and effect. So this is saying, if we have this equation and I put it into Desmos, which you're not allowed to use on the test tomorrow, but this is what it's suggesting is, give me that equation, but change that 1/2 to a -2. So if that thing were a -2, how would the graph change? And so you have to know what the number in front of a parabola, what it's responsible for. So the number in front of a parabola is the stretch of a parabola. So it's either super wide or super narrow. It's facing up or it's down, but that depends on whether it's positive or negative. So the number in front changes like the stretchiness of that parabola. So if we make that 1/2 and we turn it into a -2, the first thing I notice is that the parabola was facing up because it's positive, and now it's facing down because it's negative. So what I know, the first change that I would notice is that it's upside down. So if I took that equation and I put it in Desmos and then I made that 1/2 a -2, it would automatically be upside down. It used to be regular up, now it's down. And the other thing that we messed with is the number itself. So we didn't just change whether it was positive or negative, we changed the number. And making it to a 2 makes it narrow. Fractions make things wide. And I've done this before. But if you think about 1/5 x squared versus 5x squared, you would think that 5 is a bigger number, so it would make it really wide, right? But let me start both of these at the same place. 5x squared from that middle, think about slope. I know it's not a slope because it's not a line, but let's go up 5. 1, 2, 3, 4, 5, and over 1 in each direction because it's a parabola. So there you go, up 5 over 1, very narrow. Now think about 1 over 5. Go up 1 and go out 5. Look how wide. So think about the numbers in front as like a slope. It only works for the first outer points, meaning this idea only gets you from the middle point up and out only one time. So you can't just keep going up 1 over 5, up 1 over 5 every single time because that'll make a V shape, not a U. Okay, but you can use this strategy to get 1 point over in each direction. Okay. And so that's why a 1/5 makes it super wide versus a 5 is like a 5 and out 1, and a 1/5 is up 1, out 5. So that out 5 on the bottom makes it super wide. Okay, same kind of idea here, right? We've got this equation, that thing, and before I even look at the graph, let's pretend I don't even know what it looks like. I know it's a U shape. I know it's been moved down 3, and I know it's upside down, and I know it's kind of narrow based on that too. So we've got like a narrow-ish parabola that's been moved down 3, and it's facing upside down. So here it says on the same axis, meaning don't draw me another picture. Using this grid line, sketch this graph. So what immediately jumps out at me is that back number is the same as this back number. So if I'm graphing two different parabolas and they have that one number in common, then they're going to have one dot in common on the picture, and that's this dot right there on the y-axis. So I'm just going to rough sketch the fact that this graph and this graph share a point in common. But other than that, besides the fact that it's a U shape, this one's facing up, this one's facing down. This one is narrow, this is wide, kind of the way I explained here. So 1/4, so all I have to draw this is put that point in common, make it be out and up. And that's full credit. You can exaggerate this wideness as much as you want because there are no tick marks on here. So it doesn't matter if it's like out really wide. I don't want you putting tick marks. I want you showing me that you know that these two things are in common on the equation, so they have this point in common on the parabola. I want you to show me that you know that this face is down and that this face is up and that this is narrow and this is wide because that number 1/4 stretches me. All right, but that's all I'm looking for in the picture. Okay, one last thing here. I said this in class, that you can go from here to here to here. That would be called the algebraic step because you're using algebra, you're using the equation to get these pieces of information, and then you do the graph part. But I prefer, at least temporarily, let's go this way because you guys are really good at sketching stuff. I've explained this like in questions 4 and 5. You should be able to tell me something about this graph, that it's upside down. 4 would make it narrow. Remember, wide would be a fraction, and that it's gone up 4. So if I go up to 4 and I put a back dot there, that's this number here. And then that negative 4x squared tells me I should move down 4 and out 1. So if I go down 1, 2, 3, 4, and out 1 in each direction, I get a nice pretty parabola, and then I can answer all the questions. I can say the vertex, which is here, has an address of 0, 4, and I can say that the x-intercepts are here, and that's negative 1, 0, and 1, 0. So you should be able to sketch it, which you just did, right? Like you took the information from the equation and you know how it like manifested in the actual equation. Okay, but you also need to know how to do this algebraically, meaning no grid whatsoever. You should know how to go in this order from here to here. So let me show you the algebraic portion of it. Okay, in this case, the vertex and the y-intercept are the same. In this unit and this unit only, okay? But either way, what do we know about y-intercepts? That the x is 0. All y-intercepts always, always, always have an x of 0. And we know in this unit, vertex and y-intercept are the same thing. So if someone's asking you for the vertex, they're really asking you for the y-intercept. If they're asking you for the y-intercept, then you need to make x 0. So I go to the equation. Here's the equation. I'm going to make x 0. See, I literally just made x 0. And then I'm going to do some work. I'm going to PEMDAS, essentially. I'm going to do order of operations. Negative 4 times 0 is 0. Bring down the plus 4. That's it. So if I do this, 0 went in. Notice again, the x is 0. So in an ordered pair, the first number is x, and the second number is what we got. 0 went in, 4 came out, and look, the 0, 4 is the same as that 0, 4. So algebraically, meaning from the equation, if somebody asks you for the vertex, all you need to do is go to the equation and replace the x with 0, and then get this to be one number, and that one number will be your output. So you input 0, and you output a number, and that's your vertex. Otherwise known as your y-intercept, because again, the x is 0. The other part is finding x-intercepts algebraically. And again, algebraically literally means from the equation. So if somebody says to me, find the x-intercepts, all I know about x-intercept is that the y is 0. So I go to the equation, I'm going to copy it as is, okay? And I know that in x-intercepts, I have to make the y 0. There is no y, fine. We just make it be y. We can do that. This is normally y, so let's make it y. X-intercepts, make y 0. Here's your y, make it 0. And now we'll just do some regular old solving. If you don't like the equals 0 on that side, no problem. Scratch it out and put it on the other side. And now solve. Get x by itself. So the first thing that we want to undo from that x is this thing, and this thing. So we have to specify like an order. We always want to get rid of the addition and subtraction first. So we'll undo addition with subtraction. Bring down that negative 4x squared. 0 and negative 4 is negative 4. Again, now we've got two things to get rid of. Big number out in front, teeny tiny number up here. Always get the big number out first, so divide by negative 4 because that's multiplication. So we undo multiplication with division. Negative 4 divided by negative 4 is 1. Almost done. We've got x by itself. To get x by itself, we have to undo that 2 there. So we undo a square with the square root. The square root of x squared is an absolute value of x. The square root of 1, what number times itself is 1, is just 1. And now to drop the bars, we have to walk in both directions. So if we walk to the right one, we're at 1. If we walk to the left one, we're at negative 1. And if we really want to be precise, because we were asked about x-intercepts, there were 2 answers here. Remember, x is the first number. So there's 1, there's negative 1, and this is a y. What do we know about all x-intercepts? The y is 0. So notice you are going to match that and that. So if you're going to use the equation, you have to either replace the x or the y with 0, depending on which one you're solving. If you're solving for the vertex, the y-intercept, the x is 0. If you're solving for the x-intercept, the y is 0. And then you're just straight up going to that equation and doing some solving, rearranging some things. The other option is to take this and graph it and then use the graph to get these. You just have to be careful that you know what these are for sure before you write them down. If you don't know for sure from the graph, then you can use the algebra to get your answer. Okay, hope that helps.